the modulus and argument of a complex number. If I have a number that's a complex number that in what we call Cartesian form is a plus bi, the modulus is the length of it. Now, what do I mean by length? Well, if I'm going to draw this on an Argand diagram, this is my real axis and my imaginary axis, then my number z is, doesn't really matter, over here somewhere. Let's pretend it's over there, right? That is z. If you like, well, it's a plus bi, so its horizontal coordinate is a and its vertical coordinate is b. The modulus is the length of this line, its distance from the origin. And Pythagoras will tell you that's a squared plus b squared square root for the hypotenuse. So mod z is the square root of a squared plus b squared. For example, suppose my z was 5 minus 3i. So it's actually 5 minus 3i. It's over here somewhere. That's okay. I don't care which quadrant it's in. I'm just going to use the same thing, Pythagoras' formula. The length of my complex numbers line, the mod of my complex number, the modulus, is equal to the square root of 5 squared plus 9 squared. No, 3 squared. I'm already squaring it in my head. Well, that is the square root of 25 plus 9, which is the square root of 34. And 34 does not have any perfect square factors, so that's my length. Okay, that's the modulus. What about the argument? The argument is this angle here, theta. That's my argument of my complex number z. Now, remember, this angle ends up at the same place as once around plus it, twice around plus it, etc. The coterminal angles all end up at the same place. So by convention, we always give the principal argument. Okay, so let me make you a few notes. So the argument, arg of z, is equal to this angle here. Well, how do I get that angle there? Well, it's actually the tan of this angle is opposite on adjacent, b over a. So the argument is the inverse tan of b on a. And that is negative pi is less than the argument is less or equal to pi. So the argument could be pi, which is over here. If we go back the other way, negative pi is correct, but the principal argument, let me get another colour and write it like that for you. The principal argument, notice which spelling of principal it is. It's the principal of the school principal. The principal argument is between negative pi and pi, but if we go over here, the principal argument is actually pi, not negative pi. Now, you will also see this written with a capital A for capital A arg. Our textbook specifically says that the principal argument is given with a capital A. Really, I'm not sure I'm consistent enough to make that distinction, but the textbook claims that they always will. So let's try an example of the argument. E.g., if my complex number is minus 2 plus 5i, then I want to work out the argument, and I want to work out the principal argument. Well, let's make a quick sketch. My complex doesn't have to be perfectly neat. My complex number is -2 plus 5i. So we're looking at this angle here. Okay, this was z equals -2 plus 5i. So my arg of z is going to be, well, because I'm in the right place here, I'm going to get 5 over -2. Now, if I ask my calculator for that, what's it going to do? It's going to give me a negative. It's probably actually going to give me this one down here for negative tan, for inverse tan. So what I have to do is work out what I'm looking for. This angle here is pi minus my argument. I'm actually going to do it the way the textbook does it. Instead of doing this, I'm going to put a little theta in here. And I'm going to say theta is inverse tan, and do it myself. So the opposite, the vertical, is 5, and the horizontal is 2. And don't worry about the negatives, because my calculator might not give me what I'm hoping for. Just work out this angle, and then pi minus it. So you get your calculator, and you ask it for this. Make sure your calculator is set to radians. If you do that, you'll get something like 1.1903 and a whole lot more. But I actually want this. The argument, I'm trying to learn to use the textbook's convention. The argument of my complex number is pi, 180 degrees, minus that theta. 1.1903, etc. Again, get your calculator, and then let's round this one off to 2 decimal places for our final answer, 1.95.